So welcome everyone to my talk, and it's called Responsibility for the Harm and Risk of Security Flaws. What a mouthful. This is a very complex problem, and it's different than most of the engineering complex problem. As my co-author usually says, this kind of problem is a ill-defined problem. And why is it ill-defined? Well, there are a couple reasons for that. One of them is that the problem, the solution to the problem, might change depending on the context of that problem. We do not have all the information that we need in order to solve this problem. It's not like solving an equation. You have to get to a solution without understanding all the inputs, or even without having all the inputs that you need. Lastly, as soon as you solve this problem, the solution comes and bites you. In other words, the solution changes depending on the way that you solve the problem. So it's even an understatement to actually call this just one problem. It's actually several problems. They're tangled together, and the solution will come and bite you. So in order to solve this kind of problem, a lot of things are needed. One of them is we need to understand the things that we believe. We need to revisit those. We have to know what they are, and based on things that we know, we can actually solve the problem. And sometimes we take a lot of things for granted. For example, what is software? We all think we know what software is. We consume software, we produce software, but what software really is? I'm pretty sure different people have different answers for that. We're going to spend about 7 minutes revising this very simple topic, and then we're going to jump into the discussion about the responsibility for the harm and risk. But one of the things that people actually ask and wonder is, does knowing what software is really matters? Does it matter at all? Why should we revise this kind of concept? So let me tell you a story. And this story is about 5 monkeys in a cage. Has anyone ever heard about this experiment here? Interesting. So the experiment, it consists of putting 5 monkeys inside a cage. Then you put stairs. On the top of the stairs, there are a couple of bananas, and there's a sprinkler. And the sprinkler has cold water. As soon as the first monkey realizes there are some bananas on the top of the stairs and tries to climb, he's going to touch the stairs, and that will turn on the sprinkler and will shower all the monkeys with cold water. No monkey actually likes to get, a shower of cold water. So what they're going to do is they look at the monkey who just touched the stair and say, hey, you must have done something wrong. And they go and punch the monkey. The next monkey comes and tries to do the very same thing with the very same results. And then comes the next monkey and the next, until a time that all the monkeys try to do the very same thing without success. And then they learn, okay, if I go and try to grab the bananas that are on top of the stairs, the sprinkler will go off, and everyone's going to get cold shower, and they're going to beat me up. So I'm not going to do that. That doesn't work. The next thing the scientists do is actually turn off the sprinkler. And guess what? The same behavior happens. The monkeys don't go for the bananas because they think something bad will happen. In the third phase of this experiment, scientists start replacing each monkey. And the first monkey tries to do the same thing that the other monkeys tried to do before. And he would succeed because this sprinkler is no longer working. However, as soon as he goes to the stairs, the other monkeys come and beat him up. And goes on. And suddenly all the monkeys are doing what, hey, it was the way we always done here, without knowing why things are done that way. So it's really important to revise our very basic concepts, such as what software is. Moving forward, without revising this kind of things, has a name. It's called insanity. So the first view of software is actually that software is a product. Software is much like an appliance. You go, you buy in a store, it comes in a big box, you bring home your washer and dryer, you install, you use it, you pay once, it's yours to keep. I work for Symantec. We ship softwares in yellow boxes. This definition works wonders for me. It works wonders for, VisiCalc, Lotus 123, WordStar, a bunch of products that you have out there. But there's one difference. Software is not really like a product. When I talk about the chair, there's an incremental cost that somebody has to actually spend in order to do the second instance of the chair. If I want to do a third chair, there's a cost. Software, true to its form, there's no additional cost to do another copy. True to its form, you just copy software, and you would actually have a copy that somebody else could use for free. That doesn't work in real life because we have some features in software, such as licensing keys, we have laws that would prevent us from doing that. I'm not advocating that you copy software legally, but true to its form, software is actually something that you could copy and there's no additional cost. So this definition, although it would be very interesting as a way to market software, is not what software really is. Software is not a product. So the industry actually realized that and tried to do things a little bit different. Software today, a lot of people say, it's a service. It's like going to the dentist, right? You rent software, you pay a monthly fee, and you have software and you can use as long as you want for that amount of time, right? Again, different than in real life. If I go to the dentist, you cannot go to the same dentist at the same time. He's working on, my mouth, not yours. So that definition also doesn't work for software. We actually have to cripple software in order to make it fit that definition, right? Software is a lot more, it can do a lot more for us than it's doing when it's a service, but in order to make a marketable product, we, cripple the true potential of software. There's another definition that's worth talking about, which is software is speech. If you talk to a lawyer, and if you talk for a long time, he may even convince you that software is a speech. Why? Because there's a language and there's a grammar, right? And this definition is quite interesting from a law perspective, because as you all know, the First Amendment of this country is freedom of speech. So everything would be possible with software. You want to break digital rights management and put in a shirt and say, hey, here's how you break it, freedom of speech. You can actually do it, right? Because software would be speech. But software is a little bit different than speech, because as soon as I say, I'm going to terminate that task, the language in software actually is going to actually terminate the task that it said it's going to terminate. It's not only words, but there's action. If you ever heard the words abracadabra, probably some of you might wonder what that is. Actually, abracadabra means I create as I speak, and that's magic. Perhaps software is, kind of like magic. But here's the definition that I really like. And it is, software is a common good. You might not have heard about common good or never seen a good example of what a common good is. But a great example is actually a lighthouse. Once the lighthouse is up, every ship in the sea can use it, right? So it's just like what I was talking about software. Everyone can use at the same time for no additional cost. And there's more. You cannot prevent one ship from using the light from the lighthouse, even if the other ship paid for that, to build that lighthouse. So what happens? People are self-interest, right? People want to do whatever it's in their own benefit. Who is going to actually pay to build and maintain that lighthouse if everyone is going to benefit from that? This is why we cripple software. This is why we come up with license keys, because we want to sell. And because we can sell software and it's a profitable business, we have all the types of products that actually you see out there. So it's not actually a bad thing. But common goods by themselves are a market failure, and that's something that everyone can benefit, everyone can use at the same time, and there's no additional cost for that. Software is a common good. Now, common goods can be also common bads, if you will. For example, think about pollution. Pollution is something that I can use and you all can use, or be a victim of at the same time that I am, and fits exactly the same definition that I just said about the lighthouse. And if software is truly, on its true form, a common good, actually, vulnerability is just like pollution, and that's the byproduct of software. And whenever we think about pollution, we think about the big bad factories polluting the planet. But truth to be told is that we are all responsible for the pollution that is out there. We're all responsible for the garbage. And that's exactly what I'm going to talk during this presentation. Who is responsible for the harm and risk of software? I believe several people, several different entities are responsible. And we're going to start with the manufacturers, the people who actually create software. I think they have a lot of responsibility here, and they have been doing a lot of things to actually fix this problem. After, we're going to talk about home users, the people who use software at home. They know a little bit about software, they consume a lot of software, but sometimes they really don't know what, the actions they take entail in the large scheme of things. Next, we're going to talk about corporate users, the people who really understand software and still sometimes do some decisions that go against security. We're going to talk about security researchers and how the market for vulnerabilities actually impact all the ecosystem on security. Finally, we're going to talk about the government and what the government can actually do in order to make our lives better and in order to fix this big problem, which is the responsibility for the harm and risk of software flaws. So starting with manufacturers, I think around the 90s, a lot of the companies start noticing there was a big problem with software. The big word here is reputation. Seen in a different ways, the reputation of some companies were at stake. There were news saying, don't use products of company X. They are insecure. You're going to put your IT shop at risk if you use those products. Market leaders are usually the target of big attacks. And those guys had to rise to the occasion. And they had to actually enhance the way they created software. The days of cowboy development were over. And we had to actually create a process around how to create software to make it secure, by definition. Some companies got together. Here I have a slide on safe code. And you can see a bunch of companies that are market leaders in their own segment that got together just to write papers on how to write better software. What are companies like the safe code companies doing? Well, there's a bunch of things they're doing. First one is looking at software, not only about the development, but since software is actually conceived. Whenever you're doing design, try to do your threat model, go through code reviews, train your people on how to write secure software, not to be confused with security features. Train your QA how to find security vulnerabilities, not only bugs, and what's the difference of those things. How to use static source code analyzers, dynamic analysis, and finally, if things go bad and there's a vulnerability that is found in the market, how to respond to those vulnerabilities is also something very important. So as you can see, there's a lot of steps in order to develop secure software. And those things cost money. Now, those companies have to invest a lot of money in order to get you better software. Still, software is a very complex thing to do. For starters, there's no way to actually prove software does what it's supposed to do. That's a big problem, right? There's no way to actually say that software will actually ever end its execution. There's actually no good way of testing software to make sense that it's really doing what's supposed to do. The best way that we know is actually get some people to test your software, to do some automation, and that costs money. In fact, if you're going to invest in security and you're going to shoot for 0 vulnerabilities, probably if you achieve that, 0 vulnerabilities in your software, you over-invested in security. So it's a big problem. No enterprise likes to over-invest. So what to do about that? Well, there's certainly some things that we actually know. Some of them is that the more QA I put in a process, the better it's going to be in my software because there's more people testing. And also, if I hire really good developers, people who are actually trained on security, they're going to do better software. So one of the solutions, one of the things that the industry actually agrees is that if I hire fewer developers, but really good people, and more QA, I'm going to have better software. It doesn't matter if you have the security superstar in your team, the padlock, if you have the shoelace. You really have to kill the weak link, right? You really have to make sure that the entire team is doing the right thing, not only one person. Now, this is one way to actually invest in security. The other one is to look at the competition and see what they're doing. So we have the problem about the bear. If you look at the competition, you're going to see that not everyone is investing in security as much as the leaders, the market leaders, are investing. So what's going on? Well, basically, software security is much like running from a bear. Let's say a bear just enters that door and everyone runs. Bear can run really fast. Actually, some bears can run faster than racing horses. But you don't have to run that fast in order to run away from the bear. All you have to do is run faster than the person next to you, and the bear is going to get that person. So really, what's going on here is the market, aside from the leaders, is not looking at the next best player, but really at the worst player. And as long as you stay a little bit ahead of the worst player, this is all that you need to do in order not to be in the front page news. Now, this is very true for large companies. What about the small companies? What if you go to a CEO of a startup and ask, hey, what do you think about security risk? And instead of saying that security is about the chance of attack happening times the damage potential, which is kind of the way most people know risk, he's going to say, well, Cassio, risk for me is about making the payroll next month. That's what risk is for a startup. So what startups really want to do is survive, plain and simple. In the beginning, when they just start doing a product, they don't have a lot of assets. They don't have a lot of data from their users. They don't have a large market share. So why invest in security? They have this market risk, and the security risk is actually very small. So as my friend Brian Chast usually says, think about Twitter, right? Twitter had a bunch of vulnerabilities related to, security. And why? Because, until they get to a point where they're stable, they're a profitable company, they're doing good, they're not going to care about security. And this is, makes perfect sense. So moving from the manufacturers to adopters of software, let's talk a little bit about corporate users and home users. Home users see software in a very interesting way. Users really want features. Consider these two cars and think they are software products. First one costs this much. Here's a picture of it, and there's one quality. It's reliable. Next one costs exactly the same thing, but it's convertible, has rear spoiler, alloy wheels, and it's red. Which one you think consumers are going to like best? The red is looking really good, huh? So how do you make a car with a bunch of features and still charge the same price? I'll give you one hint. In order to make features, you need more developers. Remember what I said about have less developers and more QA? Well, you take away the QA that would make the reliable car, all the testing, and put them to actually build features, plain and simple. But there's a problem here. Who sees reliability? Do home users see this kind of things? Here's how home users actually see security. Product A, product B. 2 boxes, they look the same. Oh, the sticker price is different. That one must do something, but I cannot see. Right? Home users just don't see security. As Jeff Williams says, it would be really good if we had a solution, just like we have the nutrition facts, when we buy things in the grocery store, and see, oh, this is like a lot of fat in this, food, I should choose the other one, that we could actually use for software. Nobody knows how to do the security facts. That's why it's kind of blurry. It's because I don't have the answer for that. But that's something that the industry needs. Something that you can actually go and say, this is more secure than the other product, or this is a better quality because it follows this process instead of that process. So that would be a way to actually improve the market we are on. And sometimes users just use software because they're forced to, because there's a big network of people using a certain type of software. Think about, your favorite OS or social network. Sometimes you just have to go to one because that's where, everyone is using things. So how to build a monopoly 101? What you have to do here is actually build a big ecosystem. That's what companies really want to do. In how to build a big ecosystem, you need a lot of partners. How to get a lot of partners? You make it really easy to become a partner. One of the ways is actually, if you want to become a partner, if you want to do plugins for my OS, security is not going to be a problem. It's not going to get in the way. A lot of time, usability and security are at odds, right? Or even, creating new components to iOS. Why not make this bar really low? And as soon as this becomes a big market, go again, revisit this, and make security a big deal. Why not do the same for social networks? And if partners want information of my users, give all the information. And after that, think, perhaps that was a bad move. Perhaps they should be a little bit more restrictive. And the other thing about home users is just plain ignorance. How many times have you ever been to somebody's house and actually see this picture? New updates are available. I've seen several times. And whenever somebody has something like that, it's a botnet waiting to happen. It's another node. There's just, hey, look at me. I don't have the updates. People know how to exploit this computer. Add me to this botnet. So there's some education from home users that is necessary. Now, corporate users are a little bit different. Those guys usually know about security, and they know quite a lot. And sometimes they make wrong decisions. Why is that? Because there's a disconnect here. Just people, usually, whenever a new software is going to be introduced to an enterprise, several products are tested. And they're tested by the people who are going to use. And they do the very best technical analysis. However, when it comes to the decision, somebody else, maybe a VP, is going to look at the top 3 products and say, okay, so my technical people said all these 3 products are good. This one is the best. I'm going to choose the other one. Why? Well, because whenever you do a business decision like that, you have other factors that come into play. For example, a strategic partnership, right? Support, maybe just using one vendor. So there's a disconnect between the people who are going to operate things and the people who are going to actually decide what software needs to be used. A lot of times people just go with the market leaders. Nobody ever got fired for buying IBM. Nobody ever got fired for buying Cisco. I mean, those sentences we see quite a lot in the industry. And the reason is because, if something goes wrong, you can always say, hey, I did my due diligence, and those guys are the market leaders, and they're the best out there. And, that's what we decide to go with. I also want to remind people that vulnerabilities, security flaws, not only comes from code. A lot of times they come from operation and configuration. Think about the biggest breaches in the last couple of years. TJ Maxx, right? It was about configuration, was about wireless networks not being configured properly. What about Google? A lot of people say there was a good part of insider job. It's operation. Everyone here heard about social engineering. It's operation, right? There is some responsibility that comes from those large companies that are actually using software in order to actually operate and actually configure things properly. Also, another thing that is kind of funny is the way that industry spends their money. If you think that our big spending in IT goes this way, we spend some money in network and then a lot of money in software. When you talk about security spending, it's exactly the opposite, right? This is an idea from Jeremiah Grossman. And according to him, if you look at how much we spend in network firewalls, intrusion prevention, and everything else, and how little we spend in software, there's also a disconnect right there. So companies usually care about security, and they try to patch their systems. If you look at the calendar, and the number of patches you have out there, you're going to see that some companies actually created something called Patch Tuesday, right? One day of the month, there's going to be one single patch with all the patches combined to solve your vulnerabilities. Why one day of the month? Well, basically, it was because the large corporations asked for that. They really didn't want to have several patches coming as soon as possible out there, to solve their problems, because that generates confusion. Whenever you have a patch and you have 100 nodes to deploy this patch, you really have to test this thing, because it might break one of the finance applications. And if it breaks finance applications, your company is going to stop, and that's not good. The problem is, if there is a Patch Tuesday, there's another term that the industry coined. It's called Exploit Wednesday. The day after a patch, the bad guys start to reverse engineering the patch in order to actually find the vulnerabilities and exploit whoever didn't apply this patch. So there's some urgency in order to actually apply this patch. But there are some problems too. For example, the other 2 days here in the calendar, Thursday and Friday, Thursday is good. Friday probably is not good if you're talking about a company that has presence everywhere on the globe. Why? Because Friday is probably Saturday somewhere else in the globe, and you don't want to deploy a patch when you don't have enough support people on site to actually make sure that patch works. There's always, a percentage of installations that's going to fail. And if you have 100,000 nodes, this percentage is going to be significant. So Friday is not a good day. Monday is not a good day. And end of the month, if it is end of the quarter, is also not a good day. It's the quarterly freeze. You should not be installing that. So companies that actually care about security still have a hard time to actually finding a day to, get their patch out of the door. So another side of this equation is actually security researchers and what can be done in order to, make our environment more secure. I'm not going to talk a lot about, these terms such as full disclosure, 0 day, and coordinated disclosure. What I'm going to say is that coordinated disclosure, in case you haven't heard, is the new term for responsible disclosure. Because responsible disclosure was pretty much a heavy term, because if you don't do responsible disclosure, you are, the other option. So the industry decided to change a little bit. And as full disclosure, I think it's something that will eventually die. Because nobody likes you if you do full disclosure. I mean, media might like you because you generate news. But people working in large enterprises won't like you because you just told how they could be attacked. Companies doing software won't like you either because you're not working with them, you're making their customer unprotected, you're making them look bad. And the bad guys don't like you either because you just told how to use one of the exploits that nobody actually knew or the white guys didn't know about. So there's no, now there's one exploit less that they can use. So there is, probably eventually going away. But the interesting thing here is actually the incentives, in the vulnerability market. Realizing that security research is actually, some real research and there's a value. Some companies actually buy this kind of research. Why they buy the research? Actually, they buy for different reasons. One of them is actually to make a subscription model. So companies such as banks or the government could subscribe to a system where they would have first-hand information about the new vulnerabilities. And while the big companies are actually fixing those vulnerabilities, they could go and set their defense mechanisms, such as firewalls and WAFs, in order to protect their business. Right? So they pay a lot of money for this kind of things. A really good vulnerability can go for $40,000. That's a lot of money, here in the US. Let aside outside the US. So if you're a security researcher, there is this market, there's this reward for finding vulnerabilities. That sounds really nice. Now, do we have any developers here? Can you raise your hand if you're a developer? Okay. So, have you ever been paid to actually write bugs? Probably not, right? Writing bugs is something that usually it's a problem. And there were actually some companies that actually tried to pay for QA to find more bugs, kind of an incentive. What happened? Well, basically, when there was these incentives, developers and QA worked together. Developer came and said, hey, I will create that bug. And then you find that bug, and then we split the money. Sounds brilliant, right? So if you have a market for vulnerabilities, and some of them can go up to $40,000, what do you think the developer in India or China, where that money is actually a year worth of salary, is going to do? It's kind of tempting, isn't it? Even for, US, that's a lot of money. And that's a crime. So that's a big problem whenever you create this market for vulnerabilities. And there's more. One of the things that is not known is who is subscribing to this kind of service. I talk about banks, I talk about government. But what about the bad guys? Wouldn't it be nice for the bad guys to know firsthand about those vulnerabilities so they know there is no patch out there and they can use in order to exploit people? What happens if this information actually leaks? One of the companies who actually buy vulnerabilities and has the subscription model has this information leaking, go to the internet. Well, from their perspective, not much happens that is bad, right? Because chances are this is going to increase the value of their subscription. A lot of people will say, wow, there is, I could get this protection from this company, so I'm going to subscribe to the service. So there's also, this problem, which doesn't happen if you report the vulnerability to a software manufacturer. If information, for example, if a vulnerability leaks about a Symantec product, God forbid, we don't want that to happen because it would look really bad for us. A, because there is a vulnerability. B, because we let that leak and was bad for our customers. So different incentives for these people to actually, handle vulnerabilities. So finally, in the last part of this talk, I'd like to talk a little bit about what the government can do in order to solve this problem. And as I said in the beginning of the presentation, this problem is always changing. Sometimes you solve the problem and it comes back to bite you. There were a bunch of things that were done in order to compare the problem that we have with software with real life problems that we solved. And again, they sometimes are a little bit different, and we have to look at the facts of the way we solve them. One of the ways is actually treat hacking tools like we treat guns. Gun control. In other words, not everyone can carry a gun out there. Right? That's how some states are. So there's a problem here. If you do the same thing for hacking tools, what happens is the good guys, the guys who are actually going to use those tools such as, let's say, Metasploit, in order to test software and make sure that it's not vulnerable to some known attacks, can no longer use. But the bad guys can still use the software, and they will use from overseas. Because on the internet, unlike the real life, you can shoot somebody from far, far away. So this kind of analogy for loss just doesn't work quite right. You're going to take away the tools from the people who could do some good and actually allow the people that are in other countries to actually attack you with some tools that you just never had the chance, the opportunity to use to defend yourself. Another thing that you see is actually cutting internet access of people who are, who have viruses, who are spreading bad things on the internet. So I believe they use that, or they were talking about using such approach in France. So for example, if you have a computer at home and that computer is unpatched, what do? This computer one day gets a virus and starts spreading this virus, start using all the network bandwidth. And with this law, somebody could go, the ISP could go and say, okay, I'm going to cut your internet access until you get your system clean. Sounds nice. The problem is the byproduct of such law. The byproduct is we just allow monitoring to happen. And there is, a slippery slope from here. Just think about net neutrality and what's going on. We didn't even allow people to actually look at the context of what's going on in the wire, and just using quality of service, there's still a lot of damage that can be done, helping one company to succeed over another. So this is a slippery slope. That's something that we don't want to do. Such approach would allow people to actually look at everything that goes on the wire. So one of the things that could be done from the government is use its resources in order to help the companies. In order to make code that is secure, you need to do a lot of things. One of them is actually do code reviews. Code reviews are very expensive. And not all the companies out there have the resources in order to do real code reviews. So the government, as a large user of software, could go and sponsor those code reviews, help with their people to actually, make sure the product is done the way it's supposed to do to work. And if vulnerabilities are found, the government would know, tell the company would fix those vulnerabilities. Also a very interesting idea from our selfish perspective. Now, how would the American government feel if the Chinese government starts sponsoring a program like that? That might be a problem. That might be a problem because we might think, okay, should we trust the Chinese government? Are they going to really report every single vulnerability and not keep some in order to use and exploit the other people who actually use the same software? So that kind of thing actually doesn't work quite well when you look that companies sell software to several different governments and they need to actually maintain the code secure still. Another analogy that you see a lot of people doing is to compare vulnerabilities with pollution. In fact, in the beginning of the presentation, I was saying that pollution is a common good, software is a common good, and vulnerabilities are also a common good. So why not treat vulnerabilities like pollution? If you look at Dave Rice's talk at AppSec USA, he made an outstanding presentation exactly on this point, right? Let's treat it as pollution, so let's give quotas to people. If we give quotas, right, there's so many vulnerabilities a company can have in certain amount of time. If you have more vulnerabilities, you're going to pay for that, and it's not going to be cheap. Now, this is how it works in real life, but when you go and talk about software, things are a little bit different. Think about the small players. How would that work for the small players? As I just mentioned in the beginning of the presentation, the small players tend to have more vulnerabilities. If nothing else, they are doing version 1.0. They have more bugs, therefore they have more vulnerabilities. They don't care about security as we know, because they are trying to make the payroll. In the long run, what's going to happen with this approach is you're going to kill innovation. You're going to stifle innovation. You're going to kill the small players in favor of the large players. We're going to end on a planet where the only place where you can buy your electronics is Best Buy, Best Buy, Best Buy. I have nothing against Best Buy, but I like to have options. When we had only 2 browsers in the market that I could use, I don't think that was the time that you see the most innovation coming out of the internet. Now that you have several browsers competing against each other, we're in a much better position. So in the long run, if we implement something like this, we might have some problems. Now I talk about a lot of initiatives that I actually don't like. So let me talk about one that I like, and it's called the FDCC, the Federal Desktop Core Configuration. The government, the American government, is a large customer for a lot of companies. And with the FDCC, what they did is they just said, hey, here's some specs I would like you to follow. If you do follow these specs and you implement them in your products, I'm going to buy your product. If you don't do, I'm not going to buy it. And because the government is the 800-pound gorilla, it's the type of customer everyone wants, people tend to follow this kind of approach. For example, we had to implement FDCC norms in our firewall. At Symantec, we have 2 types of firewalls. We have the enterprise firewall and the consumer firewall. Guess what? The enterprise firewall implemented right away. We want the government business. While for the consumer firewall, well, there's some usabilities, there's some things that are overkill for a consumer. We decided to implement that later, right? But we had this option. Was, okay, you want to work with government, you do that. Likewise, probably coming up with some metrics or some things that companies have to do in order to sell software to the government, the nutrition facts, following a certain process, would be a great way to weed out the companies that are really looking at security from the ones that aren't. And try to, instead of doing the bare thing where you just have to run a little bit more than the slowest person, try to really set a bar where everyone has to be a little bit, at least above this bar in order to sell their products. So if you look at the software industry and compare to any other science out there, there's a lot of innovation going on. And innovation is kind of a S-curve, right? The beginning, there's not a lot of innovation, and suddenly people discover what something is about, and then there's like innovation constantly. We're heads and shoulders to any other science, heads and shoulders above any other science you can imagine. And I think we're just in the early cycles, right? A lot of friends from Europe tell me, I don't like America because there's no history in America. There's no big castles. And I say, no, you're wrong. History is happening today. We're building history, right? The setback we had in the year 2000, the dot-com bust, it's like a tiny fraction compared to what's ahead. There's a lot more that will happen in the next couple of years with regards to innovation. And if we start doing loss, we might stifle that innovation. And that's a big problem. We have a hard time defining what software is today. So imagine a couple years, probably software is going to be something completely different from what I talked in the beginning of the presentation. And loss can come and bite us if we don't do them properly. When I look at this picture, I think about babies, and I realize that whenever I met a baby, babies are curious about life. They wonder about the smells, they wonder about the taste, they wonder about everything that's around them. Truth to be told, not all the grown-ups that I met out there are actually curious about life just like babies. Why that happen? Why people lose their curiosity? Why people don't want to think about different things? To a large extent, the problem is related to our educational system, right? If you do something different in our education system, you're going to be punched. Just like the monkeys that I mentioned the experiment in the beginning of the presentation. So people stop trying to do different things and really focus in one thing. Bottom line is that it's about incentives. And that's exactly the problem that we face here. The problem of security and the responsibility for the harm and risk for security flaw is not really a technical problem. The bottom line is it's about incentives, it's about disincentives, and all those problems that I mentioned are really about economics. With that, I finished the talk. Thanks so much for being here, and I'm open for questions. So for the people who like this presentation, you can read more. There's a book chapter that I wrote about the subject. And here's the ISBN I wrote with Melissa Dark and Hina Chandri. And, it's also available with all the references for all the topics.